Howdy folks, I'm Keith Bowen. This is Hard Rock University doing some more smelting tests, and I'm cautiously optimistic today that I may have got it figured out. We shall see. Here's what I'm working on now, especially going out to Ned and Tricky Dicky. Ned in Australia and Tricky Dicky in the Philippines. Let's see if I can get this right. I have two crucibles in here. This is the one that kind of repeats the blank test I did yesterday. 1 gram of resin, 1 gram soda, 1 gram silica, 6 grams of litharge, and then it's covered with a 1/2 inch salt cap, which takes no part in the reaction, it just seals it off. This is the exact same mixture, except I've added a 1/4 gram of potassium nitrate to see how much of the resin I can react with that instead of litharge, just to minimize the lead I'm using. And this is the temperature profile, starting at 0. This is a cold oven, obviously, going up to 800 degrees in 10 minutes, then over to 1,000 degrees in another 10 minutes, pause at 1,000 degrees for 10 minutes, then go up to 2,000 degrees. I actually am setting it to 2010, so that it'll get up there a little bit quicker, and holding it there. I'm just going to hold it there, and at that point I should be able to pour. So that's the profile, that's the mix, and now we'll see what happens. So close up the kiln and hit run, and hear the generator lug down. Okay, I shall return. So while I'm waiting for the cake to bake in the oven here, let me explain the theory of what I'm trying to do. First of all, this is what the resin we're using for the recovery looks like when it's dry. This is unloaded. This is just plain, right out of the box resin. This is what it looks like after it's loaded and dried. See, it's got this really dark red look to it. Now, according to the calculations of the solution in, the solution out, and the weight of this should be running almost 11% gold by weight. So yesterday what I did was I used a standard flux formula in there for determining the reducing power of various materials, because different ores have different oxidizing and reducing potential, the ability to give up oxygen or to suck it out of other stuff, or the same reaction in terms of proton donor or proton acceptor. But anyhow, in fire assaying, you usually start with something called litharge. This is lead oxide. The idea is you want to reduce the lead oxide during the furnace to metallic lead. And in fact, let's see, where is it? This was the lead that I recovered yesterday from 6 grams of that, using the same formula, and 1 gram of the resin. This basically provides carbon and hydrogen to suck the oxygen away from the litharge to create lead. Now, when that's all blended together, the theory is, and what the hope is, the resin that has the gold in it, as it's exchanging the carbon and hydrogen for the oxygen with the lead, the gold will get stuck to the lead. The lead forms droplets, goes to the bottom of the crucible, and then at the end of the melt you pour it into that cone mold warming up there. You get a lead button, and then you cupel it. Again, we're essentially fire assaying this stuff. Now this is a cupel, and a cupel is made out of bone ash. It's kind of porous. This one's cracking. And anyhow, as you heat this lead, with oxygen, this will form lead oxide, which will soak into the cupel. The lead itself is not. The cupel repels liquid metals, but not liquid metal oxides. So as the metal oxides form and go into the cupel, this bead gets smaller and smaller and smaller until finally all that's left is the precious metals, because they don't oxidize, at least not very much. And then you wind up with a bead of gold and silver and maybe platinum group if you had any. And that is the evil plant. Yesterday we certainly got a lot of lead out of the reaction with the resin, and we will see what happens today when that resin just happens to have a bunch of gold in it too. So we still got quite a ways to go. We're through 869, so we're around here on the heat curve. So we got about 40 minutes to an hour left. This is the tedious part. I'll get back with you when I'm ready to pour. Well, I'm waiting here longer, so I did some calculations to kill some time to try and determine, assuming that this works, how expensive is this going to be? So first of all, we have to figure roughly how much consumable materials we have. We're destroying the resin, okay? That runs about $13 a pound, and 1 pound will basically recover about an ounce of gold. Then we've got the soda and the silica. Those are pretty darn cheap, and we don't use too much of those. So those are, $1.50 per ounce of gold recovered. The litharge, you use a lot more and it's more expensive. So that's going to run about $24 per ounce recovered. And then there's the energy cost. I mean, right now we're running a generator. We're probably talking 10-20 bucks total energy cost for this recovery. So assuming that we use smelting to recover the gold from the resin, we're probably looking at a cost in the neighborhood of $35 to $40 a ton for the recovery, and we cannot use the resin. So, somewhere less than $60 per ounce would be the cost to recover the gold using this method from the resin. We'll see what happens here. Okay, so we're up to temperature. Got my safety glasses on. I always want to work in some kind of a catch basin. Not only if you spill something on me, if you drop something or whatever, tend to minimize splashes on you, keep stuff from falling off the table, getting on the ground. It's just a good idea. Can't see it from there, but I've actually ground notches into the rims of the crucibles so I can keep track of which one is crucible 1 and which one is crucible 2. So this is sample 1, that one is sample 2. And now I'll go ahead and start preheating the cupels for the next operation. got a pretty good sized lead button there. Get that cleaned up. This would be number 2. So this had the nitrate in it also. A little bit of slag sticking there. A nice sized little lead button, as expected. The slag is a little more tenacious on this one. Okay. So now I need to weigh those. 4.71 grams there. 5.7 there. Not as much difference as I would have expected. Okay. Now it's time to put the Cupellation in there. That one's already melted the lead. I'm going to leave the door open. It'll drop the temperature and add air. So I Cupelled them with an open door, and I closed the door to really drive the heat up. Make sure I got rid of all the lead. Now it's time to take the Cupellation out here. Neither of those beads looks encouragingly large. That's a 0.07 gram bead. That's 65% recovery. So I have to put some silver in there and see what happens. I'm gonna fuse some gold beads together just to make it a little easier to handle. That was only 0.04, so the nitrate made it worse. Next time I'm coming back, I'll go ahead and see about using a silver import to improve the solubility. Happy prospecting and keep it safe out there.